11, which is hyperbolic functions. And this is what they are. So this is the hyperbolic sine, and it's e to the x minus e to the negative x all over 2. The hyperbolic cosine is e to the x plus e to the negative x over 2. And the rest of the functions, so like, for example, the hyperbolic tangent, that's just defined to be the hyperbolic sine divided by the hyperbolic cosine. Okay, and then the other ones are just defined similarly. So like the secant is 1 over the hyperbolic secant is 1 over the hyperbolic cosine, and so on. Okay, so that's how the rest of those are defined. Now, the interesting thing is if you take, so if you imagine this right here, if you take the derivative of the hyperbolic sine of x, okay, that's just taking the derivative here. You're going to get e to the x, and then the derivative of x is just e to the x. This derivative is e to the negative x times the derivative of negative x, which is -1. So that's actually going to be plus e to the negative x. And of course, that's just all, it's still going to be divided by 2. That is actually equal to the hyperbolic cosine. And the derivative of the hyperbolic cosine is going to be e to the x minus e to the negative x, which is equal to the hyperbolic tangent, hyperbolic sine. Okay, so with the trigonometric functions, the derivative of the sine is the cosine, but the derivative of the cosine is negative sine. Okay, but here the derivative of hyperbolic cosine is just the sine. So that's some interesting thing about hyperbolic functions. Okay, so let's do some exercises here. Starting with number 1, find the numerical value of each expression. It says round your answers to 5 decimal places. Okay, so hyperbolic cosine of log x. So that means you just take this right here and replace these x's with log 7. Like that. And this right here is just going to be 7 because e and log are inverses of each other. This negative goes up here. So it's e to the log of 7 to the -1. So that's going to be 7 to the -1. Okay, or 7 minus 1/7 over 2. You could simplify that down to, what is this, 49 over 7. So I'm just multiplying this by 7 over 7, and then minus 1 over 7 all over 2. So that's going to be 48 over 7, which is going to be 24 over 7. And that works out to be approximately 3.57143, and you round it off. Okay, the hyperbolic cosine of 7. Okay, so that's going to be e. Okay, so just put a 7 in here. So e to the 7 minus e to the -7 all over 2. And then you guys put that in your calculator. And I got 548. 31704. Now, if the interesting thing is, if you don't round this off correctly at the end, then you can get everything else correctly, and it's just that last digit. You put like let's say you put a 3 instead of a 4, then it's going to mark it wrong. You're so picky. Well, okay, find the numerical value of each of these. So the hyperbolic secant. So the hyperbolic secant is 1 over hyperbolic cosine. Okay, and so that means I just take the reciprocal of the hyperbolic cosine. So hyperbolic cosine is e to the x plus e to the negative x over 2. So I just take the reciprocal. Okay, so let me put that down here. So that's e to the x plus e to the negative x over 2. So that means that the hyperbolic secant, which is 1 over that, will just be the reciprocal of that. Okay, so that's what I'm pulling into right here. And then, of course, e to the 0, this is also going to be e to the 0, so that's 1 plus 1, which is going to be 1. And so now here, it's asking for the inverse of the hyperbolic cosine of at 1. Okay, the inverse of that. And so from here, from this previous problem, we can see that the hyperbolic cosine of 0 is going to be 1 also. Okay, because 1 over it is 1. That means it has to be 1 also. Okay, so that means that the inverse is going to be 0. Okay, because hyperbolic cosine of 0 is 1, so the inverse is, and then the inverse just takes back whatever is over here, takes it back to where it came from, so it's got to go back to 0. Okay, that's just based on the property of inverses, the inverse property, which is that f inverse of f of x has to be x. Okay. Number 3, proving an identity. Okay, I put these hyperbolic sine and cosine up here just for reference. And this is the addition angle identity, okay, which is, there's a similar one of these with trigonometric functions. So to prove something like this, now a lot of students have the tendency to like set these equal to each other and then work with both sides and simplify it down. But the proper way is to do a structure like this. Okay, so I'm just telling you this is the proper way to do it. You start with either the left side or right hand side, whichever is more complicated that you can just like simplify, which would be the right hand side in this case. This is more complicated. I mean, not complicated. So you want to start with that right there. And then you have it being equal to something, and then just do a series of steps until you get the until you get the other side of the equation. Okay, so that's what they did. They took this side of the equation, and this is that, this is that, and that's that, and then this one. Okay, so this one right here is supposed to go right there. And the hyperbolic cosine of y is 1/2. Okay, well, they've got the 1/2 there. That's going to be this part here, this part there. But the rest is e to the y plus e to the negative y. Okay. Next, the next thing that we would do in this case is you would multiply everything out. Okay. So since there's all these 1/4 everywhere, okay, that and that and that and that, it's going to give you because you're going to multiply all this stuff out. So you're going to get 1/4 here, you're going to get 1/4 here. So they just pulled all the way out. Okay. Now, apparently all of this is this. So they're asking, what's this going to be? Okay, so you're just looking, okay, so there's this times this. That's what that's going to be. It's going to be those two. E to the x plus y. Okay, because the outside ones, e to the x times e to the negative y is this. The inside ones is this. And the last one is this. Okay, so I have that. Okay, now what you're going to do is we're going to cancel some stuff. So let's see, what can we cancel here? E to the x plus y minus e to the x minus y. Those are going to cancel, okay? Then let's see what else. It looks like this one here and this one. No, I take that back. No, those are not going to cancel. Those are not going to cancel. Let's see. Wait, are they? Wait. They are going to cancel. That's a plus. They are going to cancel. Okay, never mind. I take that back. So those cancel. Okay, this one and this one combine to give you this last term. And this one and this one are going to combine to give you 2e to the x plus y. Okay, and then you can factor a 2 out of everything, so you're just left with this, e to the x plus y. That's 1/2 e to the x plus y minus e to the negative x plus y, but that's the hyperbolic sine of x plus y. Okay, because you just put x plus y here and here, then it's just going to be this with the 1/2. Okay, so number 4. Prove this identity. Okay, so the hyperbolic tangent of the natural log of x is equal to this. Okay. So remember the hyperbolic tangent is the hyperbolic sine divided by the hyperbolic cosine. Okay, so there's that. Okay, next step. Hyperbolic sine is going to be e to the, whatever this is, minus e to the negative, and whatever you're taking the hyperbolic sine of, all over 2. Okay, and then the 2's are going to cancel with each other. So you have this over this. Okay, but this e and so right here, e to the log x is just equal to x. Okay, so that's just going to go there. E to the negative log x, the negative. So what will happen is with this one right here, it's e to the log of x to the minus 1. So the minus 1 goes up here, and then e and log are inverse functions of each other, so you get x to the minus 1. Okay, and that goes going to go there. And that minus sign goes there. Okay, and so on. Likewise, the denominator is going to be x plus 1 over x. Okay, and then I don't know what they're doing here, but this x just stays the same. Oh, well. At this point. Okay, now now what they want to do is they want to get a common denominator. Okay, so that's what they're shooting for. So if you look at this whole numerator, multiply that by x. You take this one and multiply by x over x, you get x squared over x. And then this is minus 1 over x. So it's going to be x squared minus 1 all over x. And then, of course, the last step would be that these x's, they're going to cancel, and you'll just have this in the end. Okay, any questions about anything? Okay, number 5. Okay, this looks interesting. If the hyperbolic tangent is 4 over 5, find the values of the other hyperbolic functions at x. Okay, so the hyperbolic tangent is 4 over 5. This would be the hyperbolic sine over the hyperbolic cosine. It would be 4 over 5. Okay, but the hyperbolic sine is e to the x minus e to the negative x over 2. Hyperbolic cosine is e to the x plus e to the negative x over 2. These two are going to cancel. And you have that. Okay, so you have that over that equal 4 over 5. Okay, cross multiply. Okay, this times this, right there, equals this times this. Okay, so that's, and then distribute 5e to the x minus 5e to the negative x equals 4e to the x plus 4e to the negative x. Okay, so I'm going to go ahead and take this to the side there, bring this over here. So 5e to the x minus 4e to the x is just e to the x. This is going to go over as a plus 5e to the x, so that's equals 9e to the negative x. Okay, now if I multiply both sides by e to the x, then this is 1, and this is e to the x. It's actually e to the 2x, but let me write it like that. And then if I take square roots, I get e to the x is plus or minus 3, but e to the x cannot be negative, so it has to be 3. So e to the x is 3. Okay, and that means that e to the negative x is 1/3. Okay, so e to the x is 3, e to the negative x is 1/3. I don't have to solve for, I mean, I could go and say x is log 3 and then so on, but that's not what I'm after, because you'll see in a minute. Well, you'll see very quickly. Okay, because now I can calculate what the hyperbolic sine is. Okay, remember that's e to the x minus e to the negative x over 2. But e to the x is 3, and e to the negative x is 1/3. So that's 3 minus 1/3 over 2. This is going to be 9/3 minus 1/3. So that's 8/3 over 2, or 4/3. Okay, so the hyperbolic sine is 4/3. Hyperbolic cosine, oops. Let me get a different color. That's e to the x plus e to the negative x all over 2. So that's going to be 3 plus a third over 2. So that's going to be 9 plus 1, which will be 10 thirds over 2, or 5 thirds. Okay, so the one thing that I should point out is that the hyperbolic sine and hyperbolic cosine can each be attaining values that are greater than 1 or less than negative 1. Okay, that's a possibility. Okay, so that one's 5 thirds. The next one is the hyperbolic cotangent. What the? Hold on. Okay, so that next one's hyperbolic cotangent. That can just come from here, okay? Okay, because the hyperbolic cotangent is the reciprocal of the hyperbolic tangent. Okay, so I could have just said that from the beginning, and then also the cosecant is a reciprocal of the sine, so that's 3 over 4, and the hyperbolic secant is just a reciprocal of the cosine, so that's 3 over 5. Okay, so there's all of the hyperbolic functions. Okay, any questions about that or anything? Okay, great. Let's go ahead and go to the next exercises. Okay, so here they're looking for the limits as x goes to infinity of the hyperbolic tangent. Now remember, that's going to be the hyperbolic sine over the hyperbolic cosine. Okay, and hyperbolic sine was e to the x minus e to the negative x over 2, and then hyperbolic sine was e to the x plus e to the negative x over 2. These 2's were reduced, so you have e to the x minus e to the negative x over e to the x plus e to the negative x. Okay, so now as x goes to infinity, this and this go to infinity. This and this go to 0. The answer is going to be 1, but maybe I should justify a little bit more. If I multiply the numerator and the denominator by e to the negative x over e to the negative x, then I'm going to get 1. Okay, so e to the x times e to the negative is 1, minus e to the negative 2x. That's this times this. And then this one, 1 over 1 plus e to the negative 2x. Okay, and both of these go to 0. Okay, because you're taking e to the negative big number. That's like 1 over e to the big number, and e to the big number is big. So they're both going to 0. And so in the end, you're just going to get 1. Okay, so that one is 1. This one I can just skip to here. You're going to negative infinity now. I have e to the x minus e to the negative x over e to the x plus e to the negative x. Okay, now since we're going to negative infinity, this negative x is positive, and as x gets larger and larger in magnitude, this is going to go to infinity. These are going to go to 0 though. These two are going to 0. That and that are going to 0. The limit's going to be negative 1, we can see at this point, but maybe we should justify it by multiplying by a fancy form of 1, which would be e to the x over e to the x in this case. Okay, so as you distribute that in there, you're going to get e to the 2x minus 1 over e to the 2x plus 1. And then each of these is going to go to 0 because we're going to negative infinity. Okay, so the answer is going to be -1. Okay, the hyperbolic sine is e to the x minus e to the negative x over 2. As x goes to infinity, this one is going to go to 0. And this one goes to infinity. So the answer there is going to be infinity. Here, as you go to negative infinity, again, we have e to the x minus e to the negative x over 2. Okay, so what happens here is this is going to go to 0 this time because x is going to negative infinity. But negative x is, as x goes to negative infinity, negative x goes to positive infinity, which means e to the negative x goes to infinity. But then there's this negative sign right there, so that's going to be negative infinity. Okay. Secant, that's 1 over the cosine. So it's the reciprocal of the cosine, which is e to the dang, my handwriting is so bad. Let me start over. Okay, so the sine is e to the x plus e to the negative x over 2. Okay, but the secant, hyperbolic secant will be the reciprocal of that. So now we're looking at what happens as x goes to infinity. Okay, so what's going to happen is this is going to go to 0. That goes to infinity. So the answer is going to be 0. Okay, hyperbolic cotangent. Okay, so remember that's going to be the sine. No, cosine, I'm sorry, hyperbolic cosine over the sine. Okay, 2 is reduced. As x goes to infinity, that goes to infinity, that goes to infinity. These go to 0. These are going to go to 0. So you have e to the x over e to the x, and that's going to be 1. Okay, now this third one is x goes to 0 from the right. Okay, so the hyperbolic cotangent, again, that's going to be e to the x plus e to the negative x over e to the x minus e to the negative x. Okay, now as x goes to 0 from the right, what happens? This is going to 1. This is going to 1. This is going to 1. They're all going to 1, but the denominator is 1 minus 1. So the denominator is going to 0. Okay, so you're going to have, so this is going to be like 2 over 0 if you plug stuff in, which means that it could go infinity or negative infinity or perhaps be undefined. But since we have with the right-hand limit, then you can argue this way. when x is greater than 0, this denominator is positive. Okay? Because you know, you have e raised to a positive number is greater than e raised to a negative number, right? So that's going to be positive. And then, of course, this is always positive. So that's going to go to infinity. Okay, now the next exercise, which I should have put on the same page, is you're coming from the left. Okay? Here you're coming from the left. The same thing, but you're coming from the left. Again, that's going to 2 over 0. But this time, when x is negative, so coming through negative values of x, e to the x is less than e to negative x. Because when x is negative, this one is positive and this is negative. Okay? Which implies that e to the x minus e to the negative x, the denominator, is negative. And that implies that it goes that the limit is negative infinity. Part H. Okay, let's look at I. Okay, so cosecant is 1 over the sine. So I put e to the x minus e to the negative x over 2. Or in this, take the reciprocal of that would be the hyperbolic cosine. Hyperbolic sine, I mean. Okay, now as x goes to negative infinity, this piece is going to go to 0. Okay, but this piece goes to negative infinity. So you have like 2 over negative infinity, which is going to be 0. So that limit's going to be 0. Okay, this limit. And we also got to figure this out from like one of the previous ones, the sine. Okay, here we have hyperbolic sine, which is e to the x minus e to the negative x over 2. That's all over e to the x. Okay, so e to the x divided by e to the x is 1. E to the negative x divided by e to the x is e to the negative 2x. Okay, this piece, as x goes to infinity, this is going to go to 0. So that means you're left with 1/2 as the answer. Oh dear, that was kind of long. Okay, so at the beginning I showed you some of the derivatives here. So the derivative of the sine is the cosine, derivative of the cosine is the sine. And here's the rest of them for reference. I'll try to stick with sines and cosines though, but you can always look these ones up in case it comes up on the homework or something. Okay, so here we have this function here, and you should be thinking of it like this, that the square is the outer function. So when you take the derivative, so this is g of x. So g prime of x, okay, the derivative is bring the 2 down. Reduce this power by 1. And then multiply by the derivative of the inside. The derivative of the sine, hyperbolic sine is the hyperbolic cosine. Like that. Okay, so you're going to get 2 hyperbolic sine of x, hyperbolic cosine of x. Is the answer. Okay, the next one, number 8. Find this derivative. Okay, so what happens here is the outer function is e to the x. So its derivative is just e to itself, just e to whatever that is. Oops. Times the derivative of this inside part. Okay, now the derivative of hyperbolic cosine is hyperbolic sine. So that's going to be Cengage, hyperbolic sine of 6x. Times the derivative of this very inside part here. The derivative of 6x is 6. So you get that. That's 6. And we'll put it back in this order here. Because that just feels right. Okay, any questions about that? So it's just chain rule. You've got 2 inner functions, actually, 2 outer functions, I guess. You could think of it that way. So this hyperbolic cosine is an inner function when related to this e to the something, and then it's an outer function related to this 6x. Okay. Okay, so that's that one. Now, the book also talks about derivatives of inverse hyperbolic functions, and there's a list of those that are in the book. Here I've just put down the derivative of the inverse sine and the derivative of the inverse hyperbolic cosine. Okay, so we'll use this information to calculate this derivative here. First of all, so we're going to take the derivative here of this. So first of all, though, I would like to write it in such a way that we can more easily take the derivative. So this is 1/7 x, right? X over 7 is 1/7 x. And then this one is 49 plus x squared to the 1/2. Okay, so we can go ahead and take the derivative. Here, we're going to use the product rule, so it's x times this. So it's going to be the derivative of x, which is 1, times all that. And I'll go put that back in that form because it's the end of that. Plus x, this x, times the derivative of this part. But we know the derivative of the inverse hyperbolic sine is this. So it'll be 1 over the square root of 1 plus this part here squared. Okay, times the derivative of, by the chain rule, the derivative of this, which is 1/7. Okay, so that is, by the product rule, it gives us those two terms, this term and this term, from the product rule. Okay, then we have this term here. It's minus, okay, the 1/2 is going to come down. And then 49 plus x squared to the 1/2 minus 1 would be negative 1/2. Okay, times the derivative of the inside part here, the derivative of 49 is 0, derivative of that is 2x. So it's just 2x. Okay. Okay, so here we have x over, okay, as this 7 can go inside, as it goes underneath the square root sign, it becomes a 49. So it's going to be the square root of 49 plus x squared. Okay, that's going to be that term. This term, the 2's are going to cancel. You'll have an x here. This goes to the denominator as a square root of 49 plus x squared. Okay, and then this is my very favorite part. It's where these two guys cancel. Yay. And we just end up with this one. Okay, so the interesting thing here is if we ever wanted to know, for some reason we wanted to know what function, when we take the derivative, is going to give us just this, then there it is right there.